of a project I started and probably talked about months ago on my channel. Of course, I keep starting projects and pushing them aside here in this mess. Last thing you guys saw was the three-phase motor being driven off of a VFD that's being driven off of a DC to DC power supply I made. Just in testing mode on that, but I bought one of these security cameras from Harbor Freight like months ago. Installed one of them on the front of my house. It has a built-in motion sensor. It's actually bright as hell, uh, and I believe it's only supposed to be on full brightness for like a couple minutes, and then it's supposed to drop down a little bit, depending on what you throw the switch. But the way these are, these have these built-in motion sensors, which always suck. By the time you get them sensitive enough to detect a person going around your vehicles or into your driveway or whatnot, it also detects a damn cat every time a cat comes into the yard. So another project I think I showed you guys was that I tested an LED beam, and I gonna basically project an LED laser beam across my perimeter of my property, and then when somebody actually breaks that perimeter, my own homemade circuit's going to detect that and control these security lights. So here's like one of my circuit boards you guys have seen. I've used them all the time for different projects that I make. Little microprocessor on here, and this one I'm still just using it for a test because I can just turn up and down the duty cycle and select what frequency I want the output. So it comes in handy when I'm testing toroid transformers and things like that, for power supplies and whatnot. So a little different in this case. So with this, I hacked apart this LED thing, and right now all the wires cut from the motion sensor head, which is not going to be used. And I kind of figured out that they have a circuit here. It's together and ground it out. It turns off the LEDs. And I've noticed with my little oscilloscope that it was using some sort of pulse width modulation to control the brightness. Now here I got to show you guys something that happened the first time. I tried to hook up my oscilloscope earlier to circuit, my regular oscilloscope, and then this, I think it was actually when I tried to hook up this 12-volt power supply. I tried to put ground to ground on this, and it went boom, and it blew up at first the little fuse on this circuit board, and the other thing it is, it blew up the little full wave rectifier on there, the bridge rectifier. So I had to solder another one onto the back of this board. This is a brand new thing I bought today. Look at that, it's already got let the smoke out. So I fixed it. So it's back up and running. And then what I'm doing is I need an opto isolator because, again, my whatever circuit I have, if it runs from a separate power supply, I cannot ground this ground wire to the ground of my house. It goes boom. And I actually have this plug, the polarity sensitive, plugged in to where hot said hot, neutral is neutral. At least I thought I did. But anyway, my circuit needs to be isolated from that. So I'm out of opto isolators, so I need to order some. So basically, I'm using a photo, basically a same thing, photo diode and a photo detector, just kind of covered in here. So basically, you power up an LED, a photo LED, infrared. I'm sorry, not photo. Use an infrared LED, infrared detector. Photo LEDs look like this right here, which is what I will measure sunlight with when I do my dusk to dawn circuit. Oop, there's another one. I wonder where the second one went. See, my place is a mess. So it's a photo diode, basically, or a infrared LED and the detector, like you use for infrared. And that was from a detector wheel from an old printer. So I just wrapped it up in there. It'll work exactly like a chip opto isolator works, which, to show you what those look like, you guys might recognize these. Here is a commercial. This is the Allerton EMS board, that you put at your heat pumps or whatever. And for this microprocessor to switch 24 volts output, they use photo isolators, which are these. So you could only put you do it by current, but basically if these run on 5 volts, you go through a resistor, and then inside this is a LED, infrared LED basically, And then built inside is also the detector, so it's electrically isolated one from the other. And then the light is shined from the photo or from the infrared LED over to the detector. The detector is biased like a transistor, and it conducts and then output. So I need a regular transistor output. These are actually triac outputs for AC use. So they're triacs because they're taking 24 volts, switching to the 24 volt triac here. 24 volts from the power of the AC unit goes through here, and then gates these SCR triacs. Actually, triacs SCRs are just DC. These are triacs, and that's what basically these are in place of a contactor. Having a relay, these are just a digital solid state way of doing it. So I need something that looks just like these, except for I need the DC ones. I need the regular opto isolator. There's a regular like transistor output basically, which any regular photo, LED or a diode detector, whatever you want to call them. I'm in a brain fart right now. Works like a transistor, between the collector and emitter. Just don't have you're gating it with light, which is what this is doing. So I'm just using pulse width modulation to drive the LED, which then shines to the detector. The detector just basically is isolated, but it's doing the same thing. It's just every time it just put a pulse to the LED, then it conducts pulse closed. And then I just have a capacitor across here just to kind of average out those pulses so you don't see the blinking in the LED lighting there. So right now that LED is on dim. And if I basically turn my pulse width down, it'll go to full output, and it's bright as hell. Those are bright. Those will light up the whole freaking yard. One of those already is lighting up my yard like awesome when somebody walks out there. So basically, I'm going to build this controller. I'll do it with programming to basically when it gets dusk, these will come on, something like that. And I'll just be lighting up my front driveway. And then when somebody breaks that plane, it'll just boom, go full bright. That sudden change in light output will be detected by my camera system, my security cameras. Without doing anything, it'll just sense it as motion, because if you change the brightness, there'll be motion to it, and it will trigger an event, make my phone beep, when somebody comes into my yard. Right now, it makes my phone beep randomly throughout the night every time a freaking cat walks through my yard, jumps on our car, things like that. So this is really something that I need to finish one of these days. So right now my test circuit is working to drive this thing. So these are the two wires, the green and the white, going a 0.47 microfarad capacitor, and then across the opto isolator basically. And then this is the diode part, the infrared diode part will be driven directly from the pulse width modulation out in my circuit. And I'll just program in steps so it'll have brightness or whatever. And then I'll have to also have it look at one of those photo eyes I'll have on the side of the house, so when it gets dark, these come on. And then I have to have also that LED going across the yard, me monitoring that. And then when somebody breaks that, it's going to go boop, full brightness. And that is bright as shite right there. So, and I can do quite a bit. It's certain pulse widths, I get a little bit of flashing on the LED. Probably because it's only meant to be, you can only dim it so much. Dimming it like that is probably pretty good. Right about there for continuous output throughout the night. And then fuckers come in my yard. And I didn't put it on this channel, at least I don't think I did, that I caught somebody in my yard recently. Or not in our yard, I caught them going and jumping the fence. So sick to Cujo on them, or threatened to. They left. So pretty cool. This is what the pulse width modulation looks like. So basically, the more pulse width I give, the dimmer the light goes, and then reducing it will brighten the light until I don't have any output on the scope. So you can see the light in the background changing, as I change this pulse width. So it works. That's pretty cool. So basically, Might have to put together another one of these circuit boards. And I should be able to, if I just program it, don't use the buttons, I might be able to squeeze some space in the circuit board just to put a couple opto isolators on there. Maybe I could put a tool one. Because that's the other thing I need to do is I'm sure I can't, if I connect these two lights together, it might get some sort of weird ground loop or something again and more sparks. So the awesome thing about an opto isolator is for the other light, my second LED, I just have another opto isolator here. And this will be to the other, put another capacitor there. And then this will be the white and green wires. In the second one, they'll be totally isolated because its complete circuit is all this is this is just grounding out those two wires. Like if I ground these two together, it just, the lights go completely dim. Oops, and I just popped that off, but it's like, boop. It's not a good connection, but if I hold that tight, it's totally off. But, and then this here, and this light beams going between here. So it's basically isolated by light, beams of light inside these chips. So this one could basically be grounded, and then this one can just go right up to the pulse width modulator, just like the other one. And there is a resistor in here too, like a 1K. I'll have to see how much current that will be. Might not be able to drive two of those isolators off the one pulse width modulated output. I'll have to find out how many milliamps the output could do on that. A lot of LEDs run anywhere from 20 to like 80 milliamps. So these might not be that much. I'll see what their ratings are. So probably okay to drive two of them. If not, I just got to put a transistor in between the two. So it's the plan. What's this guy said? Get the electric fence transformer meant for large bulls and horses. String that. I don't know about my HOA. Probably won't like that. That would be funny though. Photo diodes basically, or LEDs, and then these are actually photodiodes against the receivers. Then they'll be gated by the light, and then they'll like drive these circuits. It's basically dimmable circuits, I guess. So it's pretty cool. I'll have to hack my other one that I already installed on the house, but now I know what I did with this, and it'll be really easy. So basically, I just need to take these two wires, run them out to my controller. It's gonna be awesome. So I do need to stick to a project and finish it because I haven't done that. So, but anyway, that's just an update there. So I'm just glad again that I finally had a bunch more of these boards made. Hey, what's up, brother? Because I think I showed you guys, I get these made 6 at a time. So there's one. Here's one. Here's one. Oh, and by the way, I soldered 3 of these together. I think I told you guys in a previous video because I thought something was wrong with my soldering or my circuit, and I was like, dang it. But what it was is this cable, not this cable, but another one I have, went bad from the programmer to this, and it didn't look bad. It was, so I made a new one, and then these all programmed just fine. So these are unfinished, these two, and it programmed the chip. So I'll have to drop voltage regulator, and which I don't need. If I have a 5-volt power supply already present, then I don't need the voltage regulator because these run off 5-volt. These little 5-volt voltage regulators, they can handle up to 30 volts DC input. Good for up to 2 amps, I believe. So I need to put another one of these together, maybe for the specific circuit, and just put a couple of temporary connections for setting my frequencies. But basically, it'll be in the program, or I could once I sockets to mount some opto isolators or something on there, so I won't need a daughter board. If I don't do that, then I'm gonna need like a daughter board, breadboard stuff, like this, with those are all little triac outputs right there with an opto isolator. But again, that's a triac output opto isolator. It's not what I need. So to order some of those or stop by Fry's. Fry's will make it really expensive. It's still too messy. I just look at the comments there. Yeah, this work table is absolutely ridiculous. That was where I used to do a lot of test circuits, and that's the same microprocessor right there. It's just that I got into these little tiny ones that I have to put on my magnifying glass to solder. I mean, because these are small. These are small. That's a 20 pin chip. It's the same exact 20 pin chip as this one, which I can just handle. So, yeah, I think it's pretty long. And then here's some of my other hacked boards, but I had the wrong size traces for the little 5-volt regulator, so it was all hacked and the wrong size holes here. I don't know how I didn't notice that in the CAD, but these are the proper size, so I can put my headers on here. So with these, whenever I have them kind of labeled all my input and outputs to the microprocessor, I can kind of make it a little different for each whatever circuit I'm doing, and then make one an input or an output instead or whatever. So these chips only have one dedicated pulse width modulated output though. But they do, I could do analog inputs and all that kind of stuff too. So where I could just turn one rotary potentiometer instead of a button and just easily, quickly adjust pulse width modulation, frequency, whatever. I kind of thought I should do that on my test thing, because right now I have to like hold the button down, see the change. And I change the modes to the speed, and then I could change the speed, which changes the frequency. 4 kilohertz is pretty popular. A lot of VFDs run at 4 kilohertz. And got it going through here. My own little design, my own little program. So, yeah. So I think these LEDs are rated to be, reduced brightness for continuous, and then when you run them like full tilt like that, which is bright, it's only for several minutes. They could overheat. You can see there's no heat sink or anything on them. So just drop them down to standby. They'll look cool running like that all night. And I got to take off this stupid motion sensor now, which looks like it'll be pretty easy. And I just have to put a plug on it, a little knockout cover or something on there. So cool. This was $54 at Harbor Freight. So glad I didn't totally blow it up forever. Now, I knew that, of course, if that one circuit fried, I could always just make my own circuit to drive the LEDs. I did try that. These seem to run on about 120 volts DC going in there. I imagine there's more circuit in there. I tried to pop one of these out, and it didn't want to. I was going to break it and make it ugly, so I couldn't. I could have just made my own transformer circuit just to directly drive the LEDs, which would bypass this thing, but it wasn't happening. So anyway, I got it working using their little circuit. It's just feeding 120 volt DC to there, and then it's got this some pulse width modulation. And earlier, one more thing before I told you how when I hooked up something else in the house that was grounded, which this power supply seems to be, the scope is grounded, boom, it was like a ground loop, and it blew up. I mean, it let the smoke out back there. I had to fix that. So I went out to my work truck and got this out. I think I've showed you guys this. This is a little tiny handheld LCD oscilloscope. So I had that thing hooked up to it, which is totally isolated because it runs on batteries. And it actually told me, this thing's actually cool, it tells me frequency and stuff, which that one doesn't. And it said 4 kilohertz is what the pulse width modulation was coming out of this that was controlling. And it only seemed to have 2 steps, just like totally bright, which wasn't grounding the signal at all, like that. Or it had like a pulse width modulated signal just reducing it. And of course, if I just touch these, it just goes out. Oops, I could touch it tight. Come on. So there, it just does nothing then. So anyway, that's kind of how it works. So basically, I'll have to just drive that with whatever I program in there. And once I get kind of some pre-programmed steps in the pulse width modulation, I'll be able to do off, dim, and nuclear bright when 2 of these suckers come on in my driveway and just blast those little pricks and get into our yard in the middle of the night. All right, with that, guys, I'll catch you later.